Hello and welcome. In this video, we will be seeing the solution approach of chef and interesting subsequence. This problem was asked in September long challenge on CodeChef. Okay, this was the second problem of September long challenge. So let me read out the problem and then we will move on to its solution approach. Okay, step by step. So what is the problem? Chef has a sequence A1, A2 and AN. Okay, this sequence has exactly 2 to the power of n subsequences. This sequence has 2 to the power of n subsequences. Okay, we will see what are subsequences. Next, chef considers a subsequence A of A as interesting if its size is exactly k. So we have 2 to the power of n subsequences in total, but we need only those subsequences whose size is exactly equal to k, and in those also the sum of all its elements is minimum possible. So we do not need all the subsequences of size exactly k, we need all the subsequences of size exactly k which have minimum sum, which have minimum possible sum. Okay, that is, there is no subsequence with size k which has smaller sum. Okay, we will see this with the help of an example. It will be really clear. Fine. So help chef find the number of interesting subsequences. Now we need to output the number of interesting subsequences. And what is an interesting subsequence? An interesting subsequence is a sequence of size k which have minimum possible sum. This is that simple. Okay, so we have in our input format, what we have, the first line contains an integer t for denoting the number of test cases. Then the second line contains two space separated integers, that is n and k, n and k. Okay, the second line contains n space separated integers a1 to an. So this is the array in the second line of the test case. In the first line of the test case, we have n, that is the size of the array, and k, which is nothing but how many size of subsequence that we need. Let's move forward. Now these are the constraints. We will come to constraints later. There is the subtask where the constraints are changed, that is n value is not less than 50 but less than equal to 20. We will see what is the importance of this line. Okay, and this is the example, this is the test example. Okay, sample test case. So let's now use this sample test case and let me explain you what the problem is asking, and how to approach the solution. Okay, this was just reading of the problem. Now let's understand what the problem is. This is the first step. Let's understand what the problem is. Okay, let's begin. So the test case that is provided to me is nothing but 1, 4, 2, 1, 2, 3 and 4. Okay, so this is nothing but we have a single test case t. This is the value of n. So the size of the array is nothing but 4, and the size of the subsequence that we need is nothing but 2. Okay, and this is the array that is provided to me, that is 1, 2, 3, 4. So array is nothing but 1, 2, 3, 4. Okay, so what are all the subsequences of size 2? What are all the subsequences in this array of size 2? So all the subsequences are 1, 2 is a subsequence, 1, 3 is also a subsequence, 1, 4 is also a subsequence. The next subsequence is 2, 3. Okay, the next subsequence is 2, 4, and the last is 3, 4. So these are all the possible subsequences in this array of size 2. Now in this all the possible subsequences, find their sum. So 1 plus 2 is nothing but 3, 1 plus 3 is 4, 1 plus 4 is 5, 2 and 3 is 5, 2 and 4 is 6, 4 and 3 is 7. Which is the minimum possible sum here? Minimum possible value of sum is nothing but 3. So these are all sums is nothing but 3, and 3 came from 1, 2. 3 came from 1, 2. So 1, 2 is an interesting subsequence. 1, 2 is an interesting subsequence. So what is an interesting subsequence? A subsequence of size 2, size is 2, 1, 2, size is 2, and it has the minimum possible sum. It has minimum possible sum. So we found out all the sums, and this contains the minimum possible sum. So how many of the subsequences have minimum possible sum as 3 and is of size 2? There is nothing but just one subsequence, that is this, has sum 3, minimum possible sum 3 and size 2. Therefore the answer of this question is nothing but count is equal to 1. So we have just one subsequence, that is interesting subsequence. We have just one interesting subsequence. Therefore, answer of this test case is given on the site also as 1. Okay, so this was what the question is asking us to do. Now let's see how we will proceed with the solution approach step by step. Let's take more example and see that part. Okay, so the first part that we need to take here is how to calculate minimum possible sum directly. How to calculate minimum possible sum directly. Okay, this is a very important part. Minimum possible sum directly. You do not need to find out all the subsequences of a length k and then sum them and then calculate the minimum possible sum there. You can do that directly. For example, if the array provided to me is 1, 2, 3, 4, 5 and 6. Okay, and the k value are different. So if k value is 1, so what are all the possible subsequences? We have a subsequence 1 of size 1, 2, 3, 4, 5 and 6. Okay, so which has the minimum possible sum in this case? Since there is just one element, so that is the sum, so minimum is nothing but 1. Okay, let's see if you can see the pattern here. So if k equals to 2, we have a sequence 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and also we have 2, 3, 2, 4, 2, 5, 2, 6. Also we have 3, 4 and so on. Okay, so which will have a minimum possible sum? You can see the minimum possible sum in all the subsequences. Even if I write all the subsequences, is nothing but this. The minimum possible sum will be this, that is nothing but 1 plus 2, that is nothing but 3. Okay, of 1 and 2. So this is the minimum possible sum that we have. Even if I write all the subsequence, this will be the minimum possible sum. Okay, it is very clear, it is very direct to see it. So if k equals to 3, we have 1, 2, 3. Okay, then 1, 2, 4. Then the subsequence can be 1, 2, 5. The subsequence also can be 1, 2, 6. Okay, subsequence can be 1, 3, 4, 1, 3, 5 and so on. So but which will have a minimum possible sum? Minimum possible sum will be this, 1 plus 2 plus 3, 1 plus 2 plus 3. Can you guys see the pattern? Can you guys see which will have the minimum possible sum always? Okay, so it is nothing but 6 of 1, 2 and 3. Okay, even if I take k equals to 4, the answer will be 1 plus 2 plus 3 plus 4 will have the minimum possible sum. So how will you directly find the minimum possible sum? You can easily see that if my array is sorted, in ascending order, then obviously the first element will be the smallest element. Okay, the second element will be the second smallest element. The third element will be the third smallest element. And to find the minimum possible sum, you will definitely need the smallest element. Therefore, if my array is sorted, then for k equals to 1, if you need a minimum possible sum, it should definitely contain 1. For k equals to 2, if you need minimum possible sum of a subsequence, that subsequence should definitely contain the first two elements. Okay, if k equals to 3 is provided, then the minimum subsequence should definitely contain, minimum possible sum should definitely be of 1 plus 2 plus 3, that is nothing but the first k elements. So what is the pattern here? It's very simple. So if my array is sorted, then in that case the minimum possible sum will be the sum of first k elements. Okay, k elements. So it is that simple. Fine. So for the sorted array, this is the answer, that is sum of first k elements. Now what if the array is not sorted? So what we will be doing if the array is not sorted? Let's see that part. So this part is actually very simple. So if my array is 4, 2, 1, 5, 6, if this is the array, so if it is not sorted, what you have to do? Just simply sort it. So it will become 1, 2, 4, 5, 6, and now find the minimum possible sum. So if k value is 1, sum of the first element, so that is nothing but 1. If k value is 2, sum of the first two elements, that is nothing but 2 plus 1, 3. If k value is 3, then sum of the first three elements, 4 plus 2, 6 plus 1, 7. So this is the minimum possible sum. This is the minimum possible sum. So if the array is not sorted, then simply sort it. So what is the time complexity of sorting? It is nothing but order of n log n. So is this time complexity valid? You have to check this using the constraints. So if you check the constraints are nothing but n less than equals to 50, okay, and a of I less than equals to 100. So in these constraints, n log n will definitely work. It will not go above 1 second. So we can sort. We can use the sort function. So what are the steps that we have seen till now? First, what we have to do, just input all the values that are given to me. Input all the values. Second, what we have to do, sort the array. Okay. Third, what we have to do, find the minimum possible sum. After sorting, find the minimum possible sum. Okay. So this is the three steps that we have done till now. Okay, now we will move to another test cases where repetitions are there, where repetitions of these elements are there, and we will see how we will approach them. Okay, but the first three steps are this, that is input all the values, then sort the array, and then simply find the minimum possible sum. So let's code this part, the small part. Let's code it. Okay, so here just take all the inputs. So use scanner. This is Java. Okay, scanner sc. You can do the same thing for C and C++, just change the syntax. Okay, new scanner system.in. Then take a test case variable. So in t equals to sc.nextInt, sc.nextInt. Okay, take an integer. After this, use a while loop. While t minus minus is greater than 0. For these many test cases, it will run. Take a variable n for the size, so int n, or take variable size for the size. Int size equals to sc.nextInt. Okay, then int k equals to sc.nextInt. So we have taken n and k. Just take the initialized array now, equals to new int size. After this, after declaration, just initialize it. So take the user input. So int I equals to 0, I less than n, I plus, oh sorry, not n, I less than size, I plus plus, and take the input arr I equals to sc.nextInt, scanner.nextInt. Okay, now this is the array that we have taken. Now sort it. So arrays dot sort. Okay, and pass the array. So the array is now sorted. Now I've told you the minimum possible sum, but let's move forward. Before writing the code for the minimum possible sum, it is very easy. You just have to add the first k elements and you will get the minimum possible sum. But do we actually require the minimum possible sum in this code? Do we have to implement it? Okay, now I have explained you what will be the minimum possible sum, that is the first k elements, sum of first k elements. But do we require to code it? Now let's move to the explanation again and see, do we actually require to code it, or it was just for the explanation part? Let's see. So after this, so let's move on to repetitions now. So what if my array contains repetition? For example, if I have 1, 1, okay, 2 ones and 2, 3, 4. These are my syntax, which is nothing but 0, 1, 2, 3, 4. Okay, so the array size is nothing but 5. Now what we have to do? It's actually very simple. So let's find out if k value is 1. So what are my total number of interesting subsequences? If k value is 1. So if k value is 1, what is the minimum possible sum? Minimum possible sum is nothing but the sum of the first k elements, which is nothing but 1, since the array is sorted. Okay, so minimum sum is nothing but 1. So what can give me the minimum possible sum? So what are the total sequences? These are my total subsequences of size 1. So I can choose this also have a sum of 1, or I can choose this also have a sum of 1. So therefore this time my answer is 2. So if I have repetitions, it is not that I will get always only one subsequence. If we have repetitions, we can get many more subsequences. You will see in further examples also. So we can have two choices. Either I can choose 1 at index 0, or I can choose 1 at index 1. okay, or I can choose 1 at index 1. So from these two we can select 1, okay, that will be the answer. Fine. So we have two choices here. So let's take one more example. So for example, we have 1 1 1 2 3 and 4. Okay, this is my array and k value is 2. So how we will move forward? So first find the minimum possible sum. Minimum possible sum will be addition of two ones, that is nothing but 2. That is the sum of the first two elements. Okay, so in the minimum possible sum, the answer is this. So what are the possible test cases, subsequences here? So these are the possible subsequences. Okay, 1, 2, 1, 3, 1, 4. Now we all know that only the subsequences that will contain two ones, will be the interesting subsequences, because the minimum possible sum is 2, and 1 plus 2 will be 3, so it will be greater. So we can only choose the subsequences which contains two ones. Okay, so we have actually 3 ones. Now in these 3 ones, how many subsequences can be formed of size 2? So it is nothing but, let's take the index 0, 1 and 2. Okay, so I can have 0 and 1, I can have 0 and 2, or I can have 1 and 2. So 3 possible subsequences are possible. Therefore the answer of this question is nothing but 3. So out of these 3 we have to select 2 ones. And that will be our answer. Okay, so let's move forward now. Let's take one more example, and in this example it will be really clear what we are doing. So here let's see, we have 1 1 1, okay, 2 2 2, 3 4 5, okay, and this time k value is 4. So what is the minimum possible sum? So since it is sorted, the minimum possible sum is sum of first 4 elements. So 1 plus 1 plus 1, that is 3, 3 plus 2 is 5. Okay, and what is the minimum possible sequence? It is nothing but 1 1 1 2. This is the minimum possible subsequence. Now I think you know how to directly find this. Okay, so now what we have? So we have 3 ones, and in the minimum possible sequence all the 3 ones are inserted. So these values are fixed. So if we have another subsequence of minimum sum that is equals to 5, so these 3 values are fixed, but we have the 4th index as empty. Why? Because we can choose either the 2 on this index, that is nothing but 0 1 2 3 4 5. So either I can choose 2 of index 3, or I can choose 2 of index 4, or I can choose 2 of index 5. Okay, so out of these 3 2's, I need to select 1 2 each time. Okay, so I think you know what we are doing here. What is selection? Just come on, think about it. What is selection? It is very, very simple now. I have taken many test cases. Okay, so what we are doing is actually very clear now. So it is nothing but, if I have 1 1 1, okay, 2 2 2 2, 3 4 5. Now if my k value is given to me as 5, so the minimum possible sum is the sum of first 5 elements, that is nothing but 7. Okay, and the subsequence is 1 1 1 2 2. Okay, so we have 3 ones, and all the 3 ones are definitely in the subsequence. So these values are fixed. Okay, now but these 2 ones have choices. If to select these 2, I have choices, that is nothing but 0 1 2 3 4 5 6. So in these 4 I can have choices. For example, I can select these indexes of 3 4. I can select 2 at index 3 and 5. I can select 2 at index 3 and 6. I can also select index 2 at index 4 5, at index 4 6, or index 5 6. So actually I have 6 choices. That is nothing but, the answer is simply 6. Okay, so I can make 6 possible subsequences of size 5 with minimum possible sum as 7. Okay, all the subsequences will be these, but the indexes are different. Okay, so what is the answer now? How will you find out the answer? It must be pretty clear now. We have 4 2's. Out of these 4 2's, I have to select every time 2 2's. So it is nothing but 4c2. Okay, what is 4c2? 4 factorial upon 4 minus 2 factorial, that is 2 factorial into 2 factorial, which is nothing but 6. So out of these 4 2's, I have to select 2 2's. Whatever is the answer is my final answer. It is that simple. The question is actually pretty simple. Okay, so if I take one more example, Now if I have 1 1 1 1 1, how many? 5 6 7 8 9 10. If I have all ones, now how many? 10 ones, that is from 0 to 9, and k value is given to me as 2. So what is the minimum possible sum? Minimum possible sum is 2. That will contain 2 ones, that will contain 2 ones, the subsequence. So how many choices do I have? So out of 10 I have to select 2 ones. Out of this 10 I have to select 2 ones, and how many sequences I will have, it will decide. So 10 factorial upon 8 factorial into 2 factorial, it is equal to 9 into 10 by 2, that is 2 to cancel, we have 45. So answer is 45. Okay, so 45 subsequences are possible in this case of size 2 and minimum possible sum of 2. Okay, so this is how we will do it. So what is n factorial? What is NCR? NCR is nothing but n factorial upon n minus r factorial into r factorial. So that is the formula that we need to use. That is the formula that we need to use. Using the test cases, we came to, using the test cases that we have created, we came to know that the approach is following NCR. The question is following NCR. Okay, now what is the next part? So we have completed many things. So we know that we have to use NCR, okay, to get the answer. Now what is the next part? Next part is how you will get the value of n and how will you get the value of r. Now here, by seeing, it is very direct. So you can say that number of 2's are 4, and you have to select every time 2 2's, because k value is 5 and 3 is here. So 5 minus 3 is 2. So we have to select this 4c2. But in the code, how will you do this? In the code, how will you do this? That is 4c2. How will you find the value of n? That is, we have nothing but 4 2's, and how will you find that 2 2's are used up? That we have to select 2 2's every time. We have to select 2 2's every time. How will you find the value of n and r? This is the next question. This is the next question that needs to be answered. So if this question is answered, then we will have the value of n, we will have the value of r. We can definitely use NCR formula, that is n factorial, and the factorial method to create the whole code. Now the only point is how will you get n and r? Okay, fine. There is a twist after this also, but till now we have done this. So we have started with this approach and we have reached this point. Now the next question that this approach is giving us is how you will find out n and r. Okay, there is a twist after this also, but till now we have reached this point. Now what you have to do? You have to now calculate the value of n and r. Okay, now let's see how to calculate the value of n and r. Let's see that. So now for calculating NCR, we need to calculate the value of n and we need to calculate the value of r. So if my example is nothing but 1 1 1 2 2 2 2 2 3 4 and 5, and k value is given to me as how much? K value is given, for example, let's take the k value as 1 2 3 4 5 6. So let's take k value as 5. Let's take the k value as 5. So we know that the minimum sum will be given to us by the subsequence of the first 5 elements. Okay, of the first 5 elements. So using this knowledge, we can easily get that how many 2's are there. We can easily get that how many 2's are there in this subsequence. Correct? So how you will find out that you have to only calculate the value of 2, of the number of 2's, not the number of 1's. It is also very simple. So just find out what is array of k minus 1. What is array of k minus 1? Why? Because 0 1 2 3 4, k value is 5. So the last element in our subsequence will be array of k minus 1, array of 5 minus 1, that is array of 4. Array of 4. So what is array of 4? It is nothing but 2. So that means the last element here is nothing but 2. So that means if this element is repeated, then we have other choices. If this element is not repeated, then we do not have any other choice. Okay, for example, 1 1 and 1 are all completely inside, they are not my last element, so we have no choices for them. If this is the last element, that is 2 is the last element, and if it is repeated further, then we have choices. Okay, so which element to choose? It is nothing but array of k minus 1. Okay, so it is very simple. Now we can use the concept of frequency arrays. We can simply use the concept of frequency arrays. Okay, now what is frequency arrays? So for example, if my array is 1 1 2 2 3, the frequency array will store that 1 is coming 2 times, 2 is coming 2 times, and 3 is coming 1 time. The frequency array will store this value. Okay, that is 1 is coming 2 times, 2 is coming 2 times, and 3 is coming 1 time. Fine. Now in the question, the constraint is given to me as the elements of the array can only be less than or equal to 100. We can use this knowledge, that is elements can be only less than or equals to 100 from 1. So that means the frequency array will only contain from 1 to 100 elements. Okay, 1 to 100 elements. So the size of the array we can take as 101. The size of the array we can simply take as 101. Okay, now how you will create a frequency array is, if this is your given array, use the elements of the given array as the index of the frequency array, That means if this is my frequency array and the element is 1, so go to the index 1, and increment its value by 1, because 1 is occurring. If 1 is occurring second time, so go to the index 1 and increment its value by 1. Okay, now 2 is occurring here, so go to the index 2 in the frequency array and increment the value. Now 2 is occurring again, so go to the index 2 and increment the value by 1. Now 3 is occurring here, so go to the index 3 and increment the value of 1. Okay, so it will say that 0 is coming 0 times, 1 is coming 2 times, 2 is coming 2 times, and 3 is coming 1 time in my original frequency array. Okay, so in this original array the elements can be from 1 to 100 only. Okay, the final maximum value can be 100 only, so therefore the frequency array size we can simply take as 101 or 100 also if you like. Okay, not take 101 because it will be from 0 to 100. Okay, the size is 101. The last index is 100. Okay, so total size becomes 101. Fine. So what we have to do is very simple. We just have to create this frequency array. Now using this frequency array, I can tell that array of k minus 1 was nothing but 2. So how many times 2 is coming? 2 is coming 2 times. So therefore total number of times 2 is coming is 2. So n value becomes 2 in this case. Okay, so what is the n value in this case? 2 is coming 1 2 3 4 5 times, so n value in this case is nothing but 5. Okay, so in the formula of NCR we got the value of n using frequency arrays. Okay, now how you will get the value of r? So it is also very simple, guys. So we know that the minimum sum will be provided by the first 5 elements, first k elements, k equals to 5. So first k elements. Now what you have to do, just in this sequence, that is in my array, just run a loop for k minus 1 times. The loop of k minus 1, that is nothing but from 0 to 4, and just check how many times this element is occurring. Okay, how many times this element is occurring. So this element will occur for 2 times. So this is the value of r. That means in this subsequence, we need 2 times. Two times. Okay, that is the value of r. So from 5, that is the total number of times 2 is occurring, we have to select 2. 2 times 2 is occurring. Okay, 5 is the total number of times that is 2 is occurring, and 2 is the number of selections that we have to perform. So from 5 select 2 each time. To make the interesting subsequence. So how you will calculate n, we know now. How do we calculate r? We know now. Okay, it is very simple. Okay, how to get which value we have to choose? So it is nothing but array of k minus 1, because this will be the last value in my subsequence. So only this value, if this value is repeated, then we have choices. If this value is not repeated, then we do not have choices. The answer will be directly be 1. Okay, so we know now many things. Okay, now let's write the code. So after getting n and r value, you just have to call the function to calculate NCR. We will write this code also. So now let's code. Now we know so many things, correct? Our approach took us to this point where we know that the answer will come using NCR, and we know how to find the value of n, we know how to find the value of r. Okay, and we just have to simply code it, and we have to create a frequency array in the process. Now let's code this point. So after sorting the array, okay, just create a frequency array. In frequency equals to new int 101. How do I got 101? Using the constraints given in the question. Okay, now for int I equals to 0, I less than array dot length, I plus plus. Now what we are doing, we are simply creating our frequency array. So frequency, this is how you create a frequency array. Frequency of arri plus plus and nothing else. So that means that I have explained this point. The element of my original array will work. The element of my original array will work as the index for my frequency array. Okay, will work as an index for my frequency array. Fine. The frequency array is created. It was this simple. So what is the frequency now that of the element that we need to have? So for example, it is original frequency. Now what is this? Array of k minus 1. Array of k minus 1. Frequency of array of k minus 1. Okay, so this is the frequency that we needed. Now this is the value of n in NCR. Okay, now let's calculate the value of r. So how you will calculate the value of r? For example, the variable name is frequency value equal to 0. Now here for int I equals to 0, int I equal to 0, how many times? Guys? K minus 1 times, that is less than k and k plus plus. So if it is k value is 5, we will run from 0 to 4 because of the indexes. Okay, now in this, if arri equal to arr k minus 1, that is the element that we need to check. If it is equal, that means we have to count how many number of times it is coming. So frequency val plus plus, that is nothing but count. We are just counting how many number of times the element that we have to check is coming inside a subsequence. Okay, so this is the value of r. Now simple, what we need to do is we need to call in system.out.println. okay, whatever value will be returned, we will print this, and we have to call the function ncr. We have to call the function ncr, pass the value of n, original frequency, pass the value of r, the frequency value, and we have to now implement the function of ncr. It's very simple, guys, to implement the function of ncr. Okay, so static long and ncr int n comma int r. Okay, what is the formula of ncr, guys? N factorial. We have to just simply return what? N factorial. Okay, so nothing but create a function of fact n factorial, divide by what we have to divide it by? We have to divide by factorial of r minus multiplied by factorial of n minus r. Okay, n minus r. Fine. So it is that simple to create a factorial ncr function. Now you have to create a factorial function. So static long fact. So in C and C++ you have to use long instead of long. In Java we are using long. Okay, int n. And how to write a factorial function? It is also very simple. So long result equals to 1. Okay, for int I equals to 2, I less than equal to n, and I plus plus. Fine. Now what you have to do? Result equals to result into I. Fine. So it is that simple. So this is the factorial function that we have, and simply return the result. Okay, so we have covered all the points. We have implemented all the points that we have seen in the video lectures. Okay, sorry, in the previous video. So that we have seen right now during explanation. So we have found out ncr, we have found out the value of n using the frequency array. This we have found out the value of r using the k value, and we have called the function ncr. Now this is the implementation of ncr using factorial. Fine. So let's now run this program here. Then let's test this program for some inputs, and then we will submit it. We will submit it on CodeChef and see whether our approach was correct or not. For example, it was 1 4 2 1 2 3 4. So the answer was okay. So we have some mistake here. We have some mistake on the line 28. It is saying that array index out of bound. So let's see. Okay, fine. So this is the error. It is nothing but I plus plus, not k plus plus. Fine. So let's now run the program again, and let's see the inputs. So it is nothing but 1 4 2 1 4 2 1 2 3 4. So the answer is 1. So we got our answer. Okay, let's take some more input. If we have 1 6 2 1 1 2 2 3 1 2 3 4. Okay, so the answer is 1. So the answer is 1 because only this will be our subsequence. Fine. So let's now just copy paste this inside that method there. So let's copy paste it. Okay, so this one will be copy paste. We will copy paste it in our CodeChef and we will submit it. Okay, So I have copy pasted the solution here. Okay, let's now run, let's now submit and see whether our code was correct or not, Okay, so we have followed an approach. Okay, we have found out a logic using NCR, and now let's see whether it is correct, whether the logic is correct or not. Okay, now it is running, and let's see. So this came as an output, and in the output you can see that the subtask is passing, but the whole answer is not passing. What can be the reason? Now the subtask is passing, that means our logic is correct. If the subtask is passing, that means our logic is correct. The logic is not wrong. We have to use NCR. But what can be the reason for, because this is not passing, the whole question. So let's see the constraints. Let's see the constraints and see what were the subtask constraints and what are the original constraints, and let's try to find out what can be the reason behind the partial correct answer, not the complete correct answer. Okay, let's see that point. So in the constraints we can see that the subtask constraint was n less than equals to 20. So for n value less than equals to 20, we are perfect, we are done, we get the value. But for n value greater than 20 and between 50, we are not getting the correct answer. So can you guys think what can be the reason behind it? Can you guys think what can be the reason behind it? Let's see the code again. Okay, by seeing the code maybe you will guys know. So inside this code, what can be the reason? We have used long. In C++ we will use long, so we will have a very large value in our hands. So the reason is n value 20 is the last value that we can get our factorial inside the range of long. Okay, if I go beyond this, then you cannot get a perfect answer for a long range. If we go beyond 20, that is 21 factorial will not fit inside a long range, inside long data type range. Okay, 21 factorial will not fit here. Okay, so if my n value is greater than 20 and my r value is greater than 20, then in numerator and denominator we have to find what we have to find. We have to find factorial in NCR, correct? So if we are talking about NCR, then we have to find factorial in each and every case. Am I correct? So that is nothing but n factorial upon n minus r factorial into r factorial, correct? Now if I have to calculate n factorial, now if my n value is 21, so I can calculate 21 factorial, but I cannot store it in a long type, in a long data type, because it is more than what long data type can store. So we have to optimize how we are calculating NCR and nothing else. Our approach is correct, our logic is correct now, but we have to optimize NCR. We have to optimize the calculation of NCR, okay, to calculate for larger values of n greater than equal to 20. Okay, for more values than 20 we have to optimize our approach. Fine, and nothing else we have to do, but we have to optimize it. Now for example, let's take a question. So if we have 1 1 1 1 1, how many times? Let's suppose we have 50 times. Okay, and k value is 25. In this case n value is 50, and when you calculate r value it will come out to be 25. So means we have to calculate 50c 25. That is nothing but 50 factorial upon 25 factorial into 25 factorial. So now these values cannot be calculated using normal approach. So we have to think of some other approach. To calculate these values. Okay, so now what we will do is we will simply use the mathematics. We will use the maths. We will use division, the cancelling part. What we are going to do, that is nothing but if we have 16 by 4, how you calculate this? 4 divided by 4, it's nothing but 4 times 4 is 16, so we divide it. So we will do something like this. Okay, we will create an algorithm for this part. Fine, so let's now see how to optimize the calculation of NCR. Fine, so what we have, for example, we have 50 factorial upon 25 factorial multiplied by 25 factorial. Okay, how can this be written? This will be simply written as 25 factorial into 26 into 25 into 27, sorry, into 28, and so on, 48 into 49 into 50. Okay, and in the bottom, in the denominator, we still have what we have. We have 25 factorial multiplied by 25 factorial. Okay, so we can we cancel it out? We can cancel 25 factorial and 25 factorial. Fine, so what remains? We remain with 26 into 27 into 28, so on till 49 into 50. And in the bottom, in the denominator, what we have? We have 1 into 2 into 3 into 4 till 24 into 25. Okay, Now how do you perform this using a pen and paper? How you calculate it without a calculator, using a pen and paper? So that is nothing but 25 will divide 50 by 2. 2 will divide 24 by 12. Okay, now here it is 48 somewhere. So 12 divide 48 by 4. So this is how we move forward. So this is exactly how we move forward in the algorithm also. We'll create a simple algorithm for this part and nothing else. For example, we have 12, okay, and then we have 8, and then we have 8. So how you divide this? How you divide this using pen and paper? You can say 2 divides this by 4 and 2 divides this by 6. Then 2 divides this by 2 and then by 3. So our final answer is 3 by 2. Our final answer is 3 by 2. But can you see that 12 by 8 can also be divided by 4? 4 divides this by 2 and 4 divides this by 3. So you will get directly in a single step 3 by 2. Instead of dividing it by common divisor, what we can do? We can directly divide it by greatest common divisor. We can directly divide two numbers by greatest common divisor, that is nothing but GCD. So we will use the concept of GCD instead of factorials. Okay, to divide, you can directly divide using GCD, greatest common divisor of two numbers, and you will get the minimum possible fraction. Okay, if you do not use GCD, then you have to divide many number of times to get the minimum possible fraction. So we will use GCD part. Now using GCD, we will be starting division of numerator and denominator step by step. Okay, now let's see that process. Okay, after this we will code for this, and the code is also very simple. Fine, so let's see that process now. So here what we have, n value is 50, r value is 25, r value is 25. Okay, we'll go from the end. So it is 50 by 25. Okay, then it is nothing but 49, I think, by 24, and it is nothing but 48 by 23, and it is multiplying like this, correct? So we will take 50 and 25, that is nothing but the value of n and r. So how you will calculate n divided by r? We will be dividing step by step, 50 by 25. So what is the GCD of 50 by 25? 50 and 25, it is nothing but 25. So divide both numbers by 25 and you will get the answer as 2 by 1. You will get the answer as 2 by 1. So this part became nothing but 2 by 1. What is behind this? It is nothing but 49 and 24. It is nothing but 49 and 24. So how you will get these values? It is nothing but n minus minus and r minus minus. 50 minus 1 is 49 and 25 minus 1 is 24. So after this step, what you have to do? N minus minus and r minus minus. Okay, you know numerator, you know denominator, you have to just perform these steps. So new n value is nothing but 49. So this is a loop running, correct? R value is 24. Again the same thing, 49 by 24 multiplied by 2 by 1. Okay, the previous value that you got 2 and 1, you have to multiply the numerator by those value and denominator by that value. Okay, so this will be stored, for example, in a numerator variable, and this will be stored in a denominator variable. Okay, so we have 2 as a numerator and 1 as a denominator. So just multiply it, so you will get this one, the fraction. Now how you will do this? 49 by into 2 is nothing but 98, and it is nothing but 24. What is the GCD of 98 and 24? The GCD of 98 and 24 is nothing but 2. Is nothing but 2. So divide both the numbers by 2. So here you will get 49 and here you will get 12. Okay, so the answer of the second step is 49 and 12. So numerator becomes 49 and denominator becomes 12. Okay, simple mathematics. And then again, what you have to do? N minus minus, r minus minus. So now what we have? We have 49 by 12. Okay, so this is nothing but the answer for these four. You can also check this. You can also check this. How? So it is nothing but 49 into 50 by 25 and 24. Correct? 25 and 24. So 25 into 2 is 50 and 2 into 12 is this. So 49 by 12 is the answer. So after 49 by 12, what we have? We have 48 here and 23 here. So now new n value after n minus minus is nothing but these only. So n value is nothing but 48 and r value is nothing but 23. Okay, so what we have here, it is nothing but 48 by 23 and multiplied by previous values. So numerator became 49 and denominator became 12. Now repeat the same process. Whatever the answer is coming for these two, calculate the GCD, divide them, then n minus minus, r minus minus. Repeat the same process till r becomes 0. Why r will become 0 first? It is nothing but 25 times. 25 times the loop will run. So 50 minus how many times the loop will run? It will run simply, oh sorry, r greater than 1. You can just simply run the loop for r greater than 1 because 1 is nothing, okay, in division. So you can simply run the loop till r is not equal to 0, r greater than 0 any times. So from 50 we will go to 26. So that is nothing but the section in the previous section. You can see this part. Okay, nothing but in the section 11 you can see this part, that the 50 will run in 26. So 50 minus 26 plus 1 will give me 25. Okay, so this is what we are doing here. So 25 times it will run, and whatever answer is present, that answer will be present in numerator. Okay, whatever you get, the answer will be present in numerator. This is how you are going to calculate NCR without using factorials. We will use the concept of GCD and a simple loop, and we will do what as children we were doing. Okay, when we were children, what we were doing at that time, we will do the same process, but we will have to code it. That means we have to write the algorithm for this, and we will have to code this. This is a simple loop learning, and the algorithm is simple. Find the GCD of n and r. Okay, divide it, store it in the values numerator and denominator, and decrement the value of n and r at every step. Okay, so this is what the loop is doing. So this is how you are calculating NCR. Okay, now change our function using factorial to using GCD. Okay, now let's begin. So we have to change this function. Okay, and now we do not need a factorial function. Fine, we will implement GCD instead of this. So we will have long. You can take numerator equal to 1 and denominator equal to 1, because it cannot be 0. Fine, so if r is not equal to 0, if r that is passed from the previous method is not equal to 0, just run a loop while r is greater than 0. Just run this simple loop, and what we have to do, at first you have to multiply the numerator is equals to numerator multiplied by n. So that is nothing but n equals to 50, correct? And denominator will become 25. Denominator equals to denominator multiplied by r. So we have 50 by 25 now. Numerator is 50 and denominator is 25. Now just have long GCD. Just call the function GCD. Just call GCD function, and in this GCD function pass numerator and denominator. So it will calculate the numerator and denominator. Okay, the GCD function will calculate the GCD of numerator and denominator, and after this just divide the numerator by the GCD. Divide equals to GCD. Okay, divide the denominator by GCD, and after this what we have to do, n minus minus and r minus minus. Decrement n and r value by 1. This will run, the loop will run again and again. We will get our value. I will show you using the debugger what are the different values coming. Okay, and after this, if this is wrong, if r is not equal to 0, just return numerator equals to 1. Just if r is not equal to 0, what we have to do, just take numerator equal to 1 and return the numerator. Okay, so this is how you are going to do this, because 0 factorial is 1, so denominator will simply become 1. Okay, nothing else. So after this, what we have to do, we have to implement our that function. Which function? GCD function. So static long GCD function, and in this what we need? In this we need two values, long n1 and long n2. You can take a and b also, long a comma long b. Now use anything that you like. Okay, so we can simply use to calculate GCD. So let's now implement the GCD function. So use Euclidean GCD if you know about it. So if a equal to 0, return b. Okay, else return what you have to return, GCD function. Just call the GCD function again, p mod a comma what, b or a, just think about it. So return a. Okay, so it's that simple, guys. It's over. The GCD function is over. It is very simple to implement. So now we have our GCD function. We have implemented the NCR function. Let's run the program, and let me just let me just show you this part using debugger. Okay, how this part is calculated. Fine, so what I will be doing is I will be having a test case where we will have 50 ones. We will have 50 ones, and k value will be 25, so that r value will become 25 in this case. Okay, let me just create the test case, copy paste it here, and then we will start our debugging. Okay, so this is our test case that we will be running. Okay, and as you can see, n value is 50 and r value is 25 when our program comes here. Okay, now let's see step by step how it will run. So just calculate, just consider on the value numerator is 1, denominator is 1. Okay, after this, after we multiply, numerator becomes 50, denominator becomes 25. GCD comes out to be 25 of 50 and 25, so GCD is here, it will be called and it will return the value. Fine. Now numerator will be divided by 25, so it will become 2. Denominator will be divided by 25, it will become 1. N value will decrement, that is become 45, and R value will decrement, it will become 24, and the loop will run again. You can see the loop is running again. Okay, now here again numerator will be multiplied by the previous number, that is nothing but 2, so it will become 98. Denominator will be multiplied, it will become 24, and the GCD of 98 and 24 will become 2. So the numerator and denominator will both be divided by the GCD. So 49, it will become 49, denominator will become 12, and you can see n minus minus and r minus minus. Fine. So this is the numerator, this is the denominator. Okay, now again the loop will run, again this same process will take place. This is the new numerator and denominator that we have. The GCD of these two values will come out to be nothing but 12. So simply divide it down, simply divide both the values by 12. So these are my new numerator and denominator. Okay, n minus minus, r minus minus, and this loop will run like this. This loop will run like this, dividing using the GCD and multiplying with the previous fraction. Okay, so this is how the loop will run. This is how the loop will run, and it will come back and it will simply print. It will simply print the answer as this. Okay, so this is how it is going to work. This is how it is going to work. Fine. So in the previous code, what we have to do, we have to change the value of NCR and nothing else. Fine. So let's change this function of NCR in our previous code. Let me just copy paste it here, and we will submit, and we will see whether we will get our partial accepted answer. Now we will get our complete accepted answer. Okay, so now I have changed that NCR function here. Okay, now let me submit it. Now after submission, now we should get a correct answer. We should get the total correct answer. Okay, let's now just wait for this to run. So as you can see, now we get our completely correct answer. Okay, so what we did, we simply used NCR function, but we have to optimize it. We do not have to use factorial because our n range was till 50, because our range of n was till 50, and we can only use factorial till 20 factorial using long data type in C++ long data type. Okay, so this is how this question is solved. Okay, so this is how you get the correct answer and the question is solved. Fine, this was the whole algorithm, the process which is followed to solve this question. There can be different algorithms for NCR as well. Okay, this is not the only one to optimize NCR. Fine.